let me ask you something, and be honest. Have you ever shipped code you didn't fully understand? I'll go first, absolutely. Generated it, ran the tests, deployed it. But if you'd asked me to explain exactly how it worked, line by line, that's a different story. And I'm willing to bet you've been there too.
Okay, so if we all kind of do it, what happens when we throw AI into the mix? These incredible tools that promise to make us so much faster. Could they actually be making this exact problem way, way worse? Are we accidentally creating what some are calling an infinite software crisis?
So that's what we're going to unpack today. This whole idea, the infinite software crisis. It's a really fascinating way to think about this paradox we're in, right? Our backlogs are shrinking, we're shipping faster than ever, but our actual understanding of the systems we're building, that might be heading right off a cliff. So here's our roadmap for today. First, we'll define what this infinite software crisis actually is. Then we'll dig into a sneaky little trap called easy versus simple. After that, we'll dissect the two kinds of complexity that AI just does not get. We'll lay out a three-phase solution. And finally, we'll talk about what all this really means for us as developers. All right, let's jump right into part one, the infinite software crisis. Now, this feeling of being overwhelmed by complexity, it's not new, not at all. Pretty much every generation of engineers eventually hits this wall. But what's happening now is different. It's bigger. The problem isn't just rhyming with the past. The scale is becoming infinite. I mean, we are generating code at a speed that is just staggering, and our ability to actually understand it all just can't keep up. You see this at major companies like Netflix, where tasks that used to take days now take a few hours. That sounds great, right? But here's the catch. When a massive production system goes down at 3 a.m. in some totally bizarre way, you really need to understand the code you're debugging. And that's the core problem. We're writing code faster than we can learn it. And if you look back at the history of software, you see this repeating cycle. Back in the late 60s, we hit the first software crisis. So what did we do? We invented C to manage it. Then in the 90s, object-oriented programming came along for the next wave of complexity. Then Agile, then the cloud, and DevOps. Each one was a solution for its time. But look at today. AI isn't just another solution in the cycle. It's a jet engine strapped to the whole thing. It enables infinite generation. The cycle is broken. It's just accelerating forever. So how does this actually happen? I mean, we're all smart, experienced people. How do we end up building these systems we can't fully explain? Well, that brings us right to our next section, the easy versus simple trap. And it's a trap we fall into constantly. This quote from Fred Brooks is just everything. He wrote it way back in 1986, and he basically said, look, the hard part of making software was never the typing, it's not the syntax or the mechanics. The real hard part is understanding the actual problem you're trying to solve. And just think about that for a second. AI has completely mastered the mechanics. It can type faster and more perfectly than any human. But that truly hard part, that's still on us. So let's break this down. What's the real difference between simple and easy? Rich Hickey, the creator of Clojure, explained this perfectly. Simple is all about structure. It means one thing, one concept, no entanglement. Easy, on the other hand, is about proximity. It's what's familiar, what's right there in front of you, what's quick to copy and paste. It's the path of least resistance. Our brains are literally wired to choose easy. The problem is, when you string a bunch of easy choices together, you almost always end up with something that is profoundly complex. And this is where AI just changes the whole game. It is the ultimate easy button. You know, in the past, we could kind of get away with choosing easy. We'd build up some tech debt, sure, but things moved slowly enough that we had time to go back and refactor it into something simpler. But now, with tools like Copilot, the easy path is so fast, so frictionless, that we barely even have time to consider the simple path anymore. So let's just walk through how this spiral happens. You start a chat with your AI assistant. Hey, add OAuth to my project. Boom, you get a nice, clean file. Easy. The next day, okay, now add support for OAuth 2. Now you've got 2 different files. Then a bug comes in. You tell the AI to fix it. A few more prompts and suddenly sessions are breaking. Before you know it, you're 20 prompts deep and you're not designing software anymore. You're just managing this tangled mess of code and constraints that you don't even remember creating. Every single step was easy, but the final result is a complex nightmare. Okay, so to really get a handle on this, we need to dissect the problem itself. Let's talk about the anatomy of complexity. Because it turns out there are 2 different kinds, and this is crucial, AI can't tell the difference between them. And for this, we go back to Fred Brooks again. He gave us this amazing framework. On one hand, you've got essential complexity. This is the hard stuff that's just part of the business problem. Like, users have to pay for an order. You can't just wish that away.
But then you have accidental complexity. This is all the junk we create ourselves to solve the problem. The clunky workarounds, the legacy frameworks, all that technical debt. And in any real system, these two are just tangled up together in a big knot. And this is not just some academic theory. Here's a real story from Netflix. They needed to refactor this old, gnarly authorization system. The problem was, the essential business rules were completely woven into the accidental complexity of how the old auth was built. So they tried pointing an AI agent at it. And what happened? The AI just couldn't handle it. It would get stuck in a loop and give up. Or even worse, it would just rewrite the code with the exact same bad patterns. It couldn't see the seams. It couldn't tell the vital business logic apart from the technical debt.
So if the AI can't untangle this mess for us, what do? Are we just stuck? Not at all. But it does mean we need a new process. And that brings us to a potential 3-phase solution. It's all about putting the human, the thinking, the planning, back in the driver's seat. And it's a very deliberate approach. It looks like this. Phase 1 is research. Here you use the AI as an analyst. You feed it all the context, all the docs, and have it map everything out for you. Phase 2 is the plan. This is where you, the human, create a super detailed human-vetted specification. And only then do you move to phase 3, implement. That's when you let the AI execute your precise plan. The big shift is that most of the work now happens in the first 2 phases, in the thinking and the plan. The power of this is huge. In the research phase, you're taking what would have been hours of digging through code and compressing it into a document you can read in 5 minutes. The plan you create becomes a paint-by-numbers guide so clear that anybody on the team could follow it. And think about code reviews. Instead of spending hours slogging through 1,000 lines of AI code, you spend 10 minutes reviewing the plan. That moment, the human reviewing the plan, becomes the single most important, highest leverage moment in the entire process. But, and this is a huge but, there's a critical catch here. This process isn't a magic wand. Going back to that Netflix refactor, before they could automate anything, the team had to do the very first migration completely by hand. Yeah, it was painful, but it was the only way they could discover all the hidden constraints and weird edge cases. You have to earn the understanding first. Only then can you actually teach an AI how to do it right. And all of this leads us to our final and maybe most important section, the human mandate. It's this recognition that even with all these amazing new tools, the hardest and most valuable part of our job is still, well, our job. Here's the danger I don't think we're talking about nearly enough. Every time we hit that easy button and let the AI do the heavy lifting on the thinking, a little piece of our engineering intuition dies. That gut feeling you get when you look at a design and just know it's bad architecture, that doesn't come from a book. It comes from the scars of experience, from those 3 a.m. production fires. If we stop doing the hard thinking, that instinct will atrophy. It will just fade away. And that brings us full circle, doesn't it? The hard part was never, ever about typing the code. It was always about understanding the problem deeply enough to know what to type in the first place. That deep understanding, that is our job. That is the human mandate. So let's do a real quick recap of everything we covered. We're in an infinite software crisis because code generation is just outpacing our understanding. We keep falling into the trap of choosing what's easy now over what's simple long term. AI can't save us from this because it doesn't know the difference between our business logic and our technical debt. A better path forward is a 3-phase approach: research, plan, implement, that puts human thinking front and center. Because at the end of the day, our future value isn't in generating code, it's in understanding the problem. So I'll leave you with this one final thought to chew on. The debate about if we'll use AI is over. That ship has sailed. We are all going to be using it. The real urgent question we have to ask ourselves now is this: when AI is writing most of our code, will we still understand our own systems?